Hey everyone, don't know if this is going to be an addendum video or if I'm going to include it as one of the videos in the Plug and Chug series. But I essentially, you know, I I'm like Plug and Chug series is going to be us just plugging away at shit, but it feels bad not explaining some like things in detail. And here I really want to talk about just how the hell do you sketch regions and how the hell do you find the limits of integration on a region, because this is very important for your success for the rest of the class. Like if you can't do this for like Cartesian coordinates in 2 dimensions, um, some of the stuff we do later on, you're just going to be completely lost. And so it's really important to it's really important to understand what's going on right now at this moment. So I think I'll I don't know. I recorded some videos that included 12, 15.2 stuff already, but I felt like I need to explain this first. So I think this will be the first video in 15.2. Anyways, what I'm going to do then is I'm just going to go through some book problems, and we're just going to figure out what the hell the region looks like and how do we express an integral. All right. So let's talk about the sketching first. All right. Uh, let's talk about sketching regions. So what do I mean by sketching regions? You're often going to be given some double integral, and you have to turn the bounds. You have to turn the bounds into a picture in the xy plane. So, for example, let's take a look at 35 from 15.2. And here we have 0, 1, okay, y root y dx dy. So what the hell does this region look like? How do I turn these boundary points that I'm erasing the circles on into a picture? So, all right, so here's x and y, right? So what do the bounds tell me? Well, x is my inside bound, right? Dx is going to be my inside bound. So this integral right here tells me that on the bottom, I have x equals y, and on the top, I have x equals root y, and that's because it corresponds with dx, all right? So what do I want to do? This means I want to draw x equals root y, and I want to draw x equals y in this picture here, right? So what is x equals y? Well, x equals y, you guys might be more familiar when I write it as y equals x, right? Is this just 45-degree line through the origin, right? It looks something like that, okay? I know it's not perfectly straight. Actually, let's see if I have a straight edge. This will do. So it'll be like, oh boy. Be like that, right? Cool. So that's y equals x, all right? Or x equals y. And now I want to draw x equals root y. Well, x equals root y is the same thing as x squared is equal to y. X squared is equal to y, which you guys might know better if you read it the other way. Y is equal to x squared, right? So you guys know what y is equal to x squared looks like. That's just a parabola, right? That goes like that. Okay? And now what? Now, this tells me, right here, this tells me that, okay, so I'm dealing with dx. So if I approach the region, okay, along something parallel to x, all right, parallel to the x-axis, right, it says that I need to hit the line y is equal to x first. So I need to hit the line y is equal to x first, and then I need to hit x is equal to root y second, okay? And that means I hit the paraboloid second. Does that make sense? So that's why x is equal to y is on the bottom, and x is equal to root y is on the top, is because if I go from negative to positive, going along the direction that's parallel to x, so that's going to be dx, then I'm going to hit y is equal to x first, I'm going to hit y is equal to x squared, or x is equal to root y second. All right, and now that tells me that this is going to be my region here on the inside. All right, and y is simply going to be what the minimum value of y is on the region. Okay, so now this is essentially y is equal to 0 and y is equal to 1, right? Here is y is equal to 0. Here's y is equal to 1, right? And y obtains the minimum at 0, and y obtains its maximum at 1. And another big thing to note is that on the outside, this outer integral, is always constant. All right. You always have constants. So 1 is a constant, 0 is a constant. Notice on the inside integral, I can have my root y's, I can have my y's, right, which aren't constants, they're functions. So yeah, but the outer integral always has to be constant. So if you're giving me outer integrals that don't have constants, I don't even need to look at the rest of your problem. I know it's wrong. Okay, so outer integral always has constants. They're very easy to find. They're the minimum and the maximum on that region. And then the inside integral is going to be the hardest. The dx integral is going to be the hardest because you have to like plot the graphs and so forth. Okay, so that's one example there. Let's see. So that's what happens when you have to sketch. So what else? Let's say I have this problem. All right. So now let's find the bounds. So what if I gave you just a sketch and I told you to find the bounds? So we're going in the reverse order, right? I'm going to give you this picture, and then you're going to have to show me the bounds, where when you sketch, you get the bounds and you have to show me the picture. So what if I have this region? Oh, I already drew it. So this is number 12, right? I have a region where this... So this is x, this is y. Here is y is equal to 1. Here is y is equal to e to the x. And here is x. X is equal to 2. All right. So, yeah, what do I do for my region? Well, I can set my integral up. Right? I can set my integral up as dx or dy. So, and in this case, there really isn't a wrong way to do it. Sometimes there will be a wrong way to do it. So, let's say for the sake of it, let's do dy dx. All right. Since this guy up here was dx dy, let's say it's dy dx. So that means, and my region is going to be this guy in here. All right. So how do I find the bounds? Right. Well, since dy is on the inside, right, this guy needs to be y equals something. This guy needs to be y equals something. And through my region, now dy is on the inside. I got to draw a line parallel to the y-axis through this region. Okay. And I look at what it hits first. Well, I hit y is equal to 1 first. So that means on my lower bound, I have y is equal to 1. Okay? And then I go through this region. And then when I leave the region, I hit this boundary up here, which is y is equal to e to the x. So that tells me the upper bound is y is equal to e to the x. All right? And then you can just drop the y's because we never write them. All right? So that's how I find my bounds on the interior. Now, the x bounds, this is going to be easier, right? Because here, from the picture, right, what's x? Well, what's the minimum value of x going to take on? Well, it's going to be when y is equal to 1 and y is equal to e to the x, right? It's when those guys meet. And so I got 1 is equal to e to the x. Well, that's x is equal to 0, right? You understand that. So x is equal to 0. You could see it from the graph is going to be my lower bound. All right, x is equal to 0. Let me just write x is equal to here because we're dealing with x on the outside. And then on the upper bound, right, I have this line right here, which is x is equal to 2. All right, it's the biggest value of x that I'm going to obtain in the shaded blue region. So x is equal to 2 is going to be my upper bound. Let's drop the x's because we never write them anyways when we write bounds. And look, there we go. Here's an integral over the region. Maybe you have some function here, some function of x and y. Let's call it f. But yeah, that's how you draw that region. Okay, makes sense. Cool. And now what? Let's see. I want to do one more thing. Yeah. Okay. Let's do this. So now, all right. If they give you a picture, you can find the bounds. But what if they just give you some equations? What if they just said, so this is number 18. All right, this is number 18 in this section. It says it's bounded by y is equal to x squared and y is equal to x plus 2. So what do you have to do? You have to draw the picture first. All right. Y is equal to x squared. What does that look like? Well, y equals x squared is this parabola. Okay? And y is equal to x plus 2. Well, here's 2, and then you got this straight line that goes like this. All right, and since it's bounded by both regions, it's going to be this guy right here. Okay? And now, let's say I want to set up a double integral. Let's say there's some function here. Which way do I integrate? Do I do dx dy? Or do I do dy dx? Or does it matter? Does it matter which way I integrate this region? And in this case, it 100% matters which way you choose first. All right? And let's think about which way you choose first. Let's try dx dy first. All right, so remember how we set the bounds up here, right? You look at the interior integral. It's dx. Right, so now I got x equals, and I got x equals. All right, and what do? Right, I draw a line through my region, which in number 12 here was parallel to the y-axis because dy was my inside guy. So I drew a line parallel to the y-axis. In my case here, if we try dx, I got to draw a line through my region parallel to the x-axis. All right, so let's do that. Cool, right? Oh, easy. It hits that guy, and it hits that guy. All right? And what's the guy on the inside first? Well, the guy on the inside is going to be, well, right, it's x is equal to something, but it's this line, right? This line is y is equal to x plus 2, and this is y is equal to x squared, right? So if I need it to be x is equal to something, because it's a boundary, well, it's the lower boundary, right? If I need it to be x is equal to something, then I can write this simply as x is equal to y minus 2, right? I just subtract 2 from both sides, and I get x is equal to y minus 2. Okay, cool. And now I hit this guy up here, right, which is y is equal to x squared, but now I hit him. So now I can say, oh, so I get x is going to be the square root of y, right? Because y is equal to x squared. And so x is equal to the square root of y, but it's a plus and a minus. So which one do I put up here in this bound? Well, obviously it looks like the plus one, right? But this should tip you off. This should tip you off. When you try to find that upper bound for dx, that should tip you off that something's going wrong. And indeed, something is going wrong. Can you guys see what's going wrong? Why is doing this not enough? Why is setting up this one integral not enough? Okay, hopefully you guys stared at this picture for a little while. Notice where I chose my dx line. I chose it near the top of the region, right? And when I choose it near the top of the region, when I follow this line in, I hit y is equal to x plus 2, or x is equal to y minus 2, the same line, all right? And then I hit the parabola, all right? Y is equal to x squared, but it's the positive side, so when I solve for x, I get x is equal to positive square root of y, okay? But that's near the top. What happens if I drew dx near the bottom instead? Right? And remember, dx is the interior integral, so I got to draw these lines parallel to x first. Right? What happens if I draw dx first? Do you guys see what happens? I come in, but I hit the parabola first? And then I hit the parabola again? And I don't hit this line here? I don't hit it at all? Right? In fact, I never hit this section. This section is not a part of my region, right? This section I bolded in dark blue. That's not part of my region. My region is the shaded part, right, between the two lines. So when I come in too low, I don't hit y is equal to x plus 2. I do not hit x is equal to y minus 2. All right, again, these guys, same line. Right? I do not hit that line first. I hit this guy. I hit x is equal to negative root y first. So now I got two guys on the lower bound. What does that mean? That means that if I did dx dy, I need to have two double integrals. I need to have this lower bound here being negative y to positive square root of y. So do you see what happens? I have these two lines hitting this region at two separate points, in two separate ways, right? Hitting this region two separate ways. The first way being hitting the straight line and then the parabola, and the second way being hitting the parabola and hitting the parabola again. So what should have tipped me off? This is bad. We don't want two integrals describing this region. That's bad, right? So how do I know on an exam? How do I know not to waste a bunch of time by trying to set this integral up dx dy? How do I know to use dy dx immediately? All right, just by looking at these equations, right? Because that's all the problem gave me. The problem gave me equations, right? And I went to draw it, and then I try to set up my region, right? Always draw this figure, okay? Always draw the picture. But how do I know not to waste time doing dx dy? And here's how you figure that out, right? So notice my region. Right? My region is y is equal to x squared, and y is equal to x plus 2. How do we set the inside bounds? The inside bounds are always going to be the functions, right? Look, the inside bounds are always going to be my functions, right? So this is y is equal to e to the x up here, right? And then down here, right, I had x is equal to root y, x is equal to y minus 2. So notice, it's always a singular x or a singular y, right? So what you want to do is, from these two equations, just solve for singular x's and singular y's, all right? So for singular y's, right, we're done, because for singular y's, I have y is equal to x squared and y is equal to x plus 2, right, for my region, right? So that means I just plug in, so I only got two equations, right, from these guys, from this right here. I only have two equations where y is by itself on the left-hand side. All right? Makes sense? They're just these guys. They're given to me. But what if I tried to solve for x? Well, here's where that problem came in, right? Here, from this equation, I get x is equal to plus or minus root y. Here, okay, that's fine. I get x is equal to y minus 2. But now if we list them all out, x is equal to positive root y, x is equal to negative root y, x is equal to y minus 2. Look, I got three equations. And here I got two equations, right? So if I try to set up one double integral on the inside, right? If I'm just trying to set up one double integral, remember, this is either y is equal to something or it's x is equal to something, right? But if I have three singular equations for x, I only got two x's here. right? I only got 2x's. So that means I need to bring in this other entire freaking double integral, and I don't want to do that. Right? I don't want to bring in more work than I have to do myself. So what do? Right? I want the inside integral to be y equals, because I only got 2 equations for y. So now, you have y equals, we do it in red. Okay. Now you see why this only ends up being one integral, because if we go back to the picture and we draw in my dy's, look, let's draw dy in here, right? Parallel to the y-axis. What happens? I hit the parabola, I hit the line. Okay? What if I do it over here? I hit the parabola, I hit the line. What if I do it way over here? I hit the parabola, I hit the line. Everywhere you draw a vertical line parallel to the y-axis, you're going to hit the parabola first, and then you're going to hit that line, right? So that means if you do this integral dy dx, well, you're going to hit the parabola, y is equal to x squared, and then you're going to hit the line, y is equal to x plus 2. Okay, so this is how you know which guy you need to integrate inside first. Okay? And then, to find the x boundaries, we just need to find the minimum and the maximum. So essentially, we need to find where the intersection is of these two guys. So so I need to find where y is equal to x squared intersects x plus 2. All right. So because that's the boundary, right? The intersection of y is equal to x squared and x plus 2 is there, and then here's an intersection point where you have the parabola is equal to the line. So to find the x boundaries, then x bounds, so you got x squared is equal to x plus 2, right? And so here's x squared minus x minus 2 is equal to 0. And essentially factoring x equal to negative 1, x is equal to 2. And so your bounds here are going to be x is equal to negative 1, x is equal to 2. All right, and then drop these guys. It's fine. Don't need the x equals y equals. Let's say there's some function in here, and this is going to be your integral over the region given in number 18. All right. So again, this was another long video, but it's very important to know how to set up your bounds, because if you get lost here, you're just done. You're toast. So this is going to be the first video for 15.2. There was another video that I already recorded. There's some limit switching going on. Look at that. There's some bound switching. But if you understand this right here, if you understand these 3 problems right here, you'll have no problem doing bound switching in the other videos. So I think I'm not going to do any more bound switching examples. I'll do some in recitation, and we're going to jump on to 15.3, which will be short videos talking about just 2 formulas really. 15.3 is going to be really short.